Well, I'll tell you a couple of strange things, things that I don't really understand.
Check. Hello guys. I'm not sure if you're able to hear me. Let me just check my feedback once before I begin teaching. I want to ensure that the audio, video, everything is going out properly. Yeah, everything looks good. Hi there. Welcome to, what is it today? We started on Monday, Tuesday, Wednesday, Thursday. Is it Friday today? Yeah, so today is day 5. Welcome to day 5 of the Bridge course series. Here I have come with a lot of concepts for class 10th, 11th, 9th, 12th students, whoever is interested, primarily designed for people who have finished their 10th. And the reason why I keep introducing the course every day is because every day we have new people joining in. So it's important for them to know what's being covered in this session so that they can make the best use and they can decide for themselves whether this whole series is going to be useful for them or not. The whole idea is we pick up concepts which I feel are important as far as all other topics in physics are concerned, because these are the concepts which will be applied everywhere. So if you struggle in these, you're going to struggle in all the following chapters, in most of the following chapters that are to come. And to avoid that, I'm here to help. So we have already finished units, then we finished dimensions, then we are into error analysis now. Yesterday we saw 4 kinds of errors, how to calculate them, right? We saw the meaning of systematic errors. Then we saw what random errors are. Then we saw the 3 other types of errors which we can calculate, absolute error, and then absolute mean error or mean absolute error. That was the 3rd one. And 4th one was relative or fractional error. And that also you can represent in terms of percentage. Hello Ashrit, it's good that you're coming live every day. It's quite encouraging to see that. So the point is, yesterday we saw that whenever you carry out a measurement in physics and when you report it, there is always some error associated with it, because as humans it's not possible for us to measure the object absolutely accurately. Like pinpointed measurement is not possible. We will obviously commit some mistake because of our nature. And how we represent data, or how we report our calculation while accounting for that error is what we saw in the previous class. Today we will see combination of errors. So remember guys, if you do not have an idea of the previous 2 classes, like day before yesterday I did the intro to error analysis, then yesterday we did a thorough discussion on some parts of error analysis and the common types of errors, and today we are going into, I would say, the final lap of the chapter. And if you're not thorough with the previous topics, you are going to struggle here. So do not try to watch this lecture unless you have watched the previous videos or you have some clarity about them already and you just want this topic to be clarified. Anyways, so we will see 1, 2, 3, 4th. Right, 1, 2, 3, 4. Right, we will see 4 types of errors, 4 types of combinations, right? So first is addition, subtraction, or I should say errors in sum/difference. Number 2, errors in product. Number 3, errors in division. And number 4, errors in quantity raised to some power. You will very soon understand what I mean by all these 4 points and why is it that we have to study these 4 points. We will understand that in terms of concept, and we will also understand it mathematically, so that you not just know the theory but you can also solve these, right? So let's get started with the first one. Whenever you have a quantity q which is equal to sum of 2 other quantities or difference of 2 other quantities, when I say plus or minus, I say either sum or difference. In fact, let me just write it like this: a plus b or a minus b. Then the question is, how do you report q this is q equal to, if there are errors associated with a and b, right? So here is the point I'm trying to make. Okay, so yesterday what we saw is, if you are trying to measure a physical quantity, let's say length of an object, then you cannot measure it perfectly. We saw that diameter problem also yesterday, right? Wherein we were trying to measure the diameter of a wire using a screw gauge. And what we saw is, every time we carry out the measurement, we will get a slightly different length. Now, all these measurements will be very close to each other, but they will still be different at the end of the day. Now, that means there is some error associated with my measurement because I'm getting different measurements for the same quantity. So, how we represent any physical quantity is its mean plus or minus. What was this quantity? If you remember, this was delta q mean, right? This is delta q mean, and this was qm. Qm was the mean of all the measurements that we carried out, and delta q mean is the absolute mean error of all the measurements. And yesterday I told you how to calculate this, right? I've taught this to you already. So any quantity that we measure, we report it as its mean value, as the mean value of all the measurements that we came across in all our trials, plus or minus absolute mean error associated with all the trials, right? Now, let's say we tried to measure A, and my A was AM plus or minus delta A, where AM was the mean. So A was a physical quantity. Let's say this physical quantity was length of object 1, and then I got A1, A2, A3, so on, A4, and up to n measurements. For n trials, I got n different values for the same object, right? This means there is some random error associated with this entire experiment. So first of all, I will calculate the mean using this. I'll just sum all these up and I'll calculate the arithmetic mean. That will be my AM. And delta A mean, what was the formula for delta A mean? This is the delta A or delta A mean. I can write this as delta A or delta A mean. They mean the same thing. Yesterday we saw how do you calculate delta A mean. You do mod of AM minus A1 plus mod of AM minus A2 plus so on plus mod of AM minus AN divided by N, right? So this is your delta A mean, and then you will put that here, and then this is how you will report it. This is telling you that your measurement is not fully accurate. You obviously have some errors. So I tried to measure A, I got some errors. Likewise, I tried to measure B and then I got some errors. Now when I'm adding these two quantities, then this is A is equal to AM plus or minus delta A. I always put plus or minus, right? Always. This error is always reported as plus or minus because it can either be less or more than the mean value, right? And then you have B as BM plus or minus delta A. So there was error associated with A. There was error also associated with B. Now when you are adding these two quantities, A plus B, then first question to you, will Q be error free? This one is very simple to answer. Will Q be error free? The answer is no, it can't be, because the quantities which are adding to give rise to Q, these quantities itself have some error. Then how will Q be error free? It will obviously have some error. Likewise, if I'm subtracting these two, Q will have some error. Now the question is, what will that error be? That is what is important to us. So the answer to this question is no, it will not be error free. Next question. Okay, if it is not error free, then what is the error in Q? Or in other words, I will also have to report Q as Qm plus or minus delta Q, correct? Because if my Q is not fully accurate, if my Q has errors, then what will that mean? That means Q will also have some mean value and some error associated with it. It is like when you carried out the experiment for the first time, you got A1 as length and B1 as length of the other object. Like first object's length was A1, second object's length was B1. When you carried out the experiment second time, then you got A2 as the length of the first object and B2 as the length of the second object. Likewise, when you carried out the nth trial, you got AN as the length of the first object and BN as the length of the second object. So in the first trial, the value of Q1 was nothing but A1 plus B1. In the second trial, the value of Q2 was nothing but A2 plus B2. In the nth trial, the value of Q was AN plus B1. AN plus B1, right? So which means in every trial, my Q is also changing. Why is that happening? Because A and B are individually different. No, like first time you have A1, second time you have A2, third nth trial you have AN. First trial you have B1, second trial you have B2, nth trial you have BN. So if A and B are changing, my Q will also change, which means when I finally report Q, my Q will also have a mean value and it will have an error associated with it. Now the question is, how will I get this mean value and how will I get this delta Q? So it's very simple, this first case is very simple. So your A is nothing but AM plus or minus delta A, your B is nothing but BM plus or minus delta B. So Q, which is your A plus B, is nothing but AM plus or minus delta A plus BM plus or minus delta B. So when you add these, what will you get? You get AM plus BM plus or minus delta A plus delta B, right? So this quantity that you see here, this becomes your Qm, and this quantity that you see here becomes your delta Q, right? So I told you, right, your Q will finally be Qm plus or minus delta Q, wherein your Qm will be AM plus BM and your delta Q will be delta A plus delta B. This was for addition. Now for subtraction, it's a little interesting. Subtraction is a little interesting. You have Q is equals to A minus B. Okay, fine. Again, carry out the same process. The same logic will hold. First of all, your A and B will be different for every trial. So Q will be different for every trial. So for n trials, your Q will be some Qm plus or minus delta Q. And I have to calculate this Qm and I'll have to calculate this delta Q for this for this operation now for subtraction. Previously I carried out for addition, now I'm carrying out for subtraction. So put your A is nothing but AM plus or minus delta A minus BM plus or minus delta B, because B is that. When you club these, you get AM minus BM, and once again you have plus or minus delta A. In fact, it is plus or minus delta A plus or minus delta B. Even here, I'm sorry, I made a slight mistake. It is plus or minus delta A plus or minus delta B, right? So in a way I can say, when you expand this, and when you expand this, there are 4 kinds of errors possible. So you have plus or minus on the outside, you have plus or minus on the inside. So there are 4 errors possible in this addition case. What are the 4 errors? Minus delta A minus delta B is the first error. Minus delta A plus delta B is the second error. Plus delta A minus delta B is the third error. Plus delta A plus delta B is the last error. 4 types of errors are possible. Even here also same. Minus delta A minus delta B is a possibility. Minus delta A plus delta B is a possibility. Plus delta A minus delta B is a possibility. And plus delta A plus delta B is the final possibility. So as you can see, QM is AM plus BM for addition. QM is AM minus BM for subtraction. But the 4 errors that you are getting is the same for addition and subtraction. The 4 errors that you are getting is the same. Now the question is, I can't choose all these 4 errors, because when I finally represent Q, I will represent Q as QM plus or minus delta Q, right? So this delta Q will only have to be 1. So I have to choose between 1, 2, 3, 4. Even here I'll have to choose between 1, 2, 3, 4. So the question is, which one will I choose? So my dear folks, whenever it comes to errors, you have to choose the error which is the greatest, which is the biggest in terms of the numeric value. Which one of these is the biggest? 4 is the biggest. Even here 4 is the biggest. Delta A plus delta B is the biggest. So I'll forget about these. I'll forget about 1, 2, 3. I will only choose 4 as my error in both cases. Here also my error will be, in addition also my error will be delta A plus delta B. Plus or minus obviously outside, like when you finally report it, you'll put a plus or minus whenever you're reporting error. But your delta Q will be delta A plus delta B. And here in subtraction also your delta Q will be delta A plus delta B. That's important. So let me just summarize quickly. When you have Q is equal to A plus B, or you have Q is equal to A minus B, and if A and B are not error free, in fact if A is AM plus or minus delta A and your B is BM plus or minus delta B in both cases, then your Q for addition is nothing but, first of all, it is some QM plus or minus delta Q, where your QM is AM plus BM and your delta Q is delta A plus delta B. So I'm choosing delta A plus delta B. Like out of all these 4, I'm choosing the 4th one because that is the biggest in terms of numeric value, and that I'm representing as plus or minus, right? So this is your delta Q, this is your QM when it comes to addition. Now when it comes to subtraction, here is I want you to pay some attention here. The subtraction also will be some QM plus or minus delta Q, because there are some errors associated with A and B. So obviously there will be some error associated with Q. So you'll have to represent Q as QM plus or minus delta Q. But here your QM will be AM minus BM. As you can see, in the previous case your QM was AM plus BM, but here it's AM minus BM because it's subtraction. But what is to be noted here, more importantly, is that error is the same. It is delta A plus delta B. You will not subtract, you will add the errors. Whether it's addition or subtraction, you will add the errors. Here also your delta Q is delta A plus delta B. Here also your delta Q is delta A plus delta B. And you're reporting it with a plus and minus, obviously. So only your QM is changing. When it comes to addition subtraction, only QM is changing, but delta Q is the same. You will have to add the errors. And I just derived it to you in the previous slide, but I also want you to understand and remember it clearly that if you see subtraction, then don't end up doing this. Like, don't end up doing this. This is wrong. You can't subtract errors. You will have to add them in subtraction. This part is right, but this part is wrong, because you will have to choose the maximum of these 4 errors, and maximum of these 4 errors is delta A plus delta B only. It is not delta A minus delta B. So this was about your addition and subtraction. So we are done with the first part. Whenever we have a quantity which is a sum or a difference of 2 quantities, then this is how we represent that quantity along with its error, right? Now let's come to product, errors in product. Number 2. If we do not get time to do numericals today, we will do it tomorrow, don't worry. But today, understand the concept at least. Errors in product. So your Q is equal to AB. Whenever you have A into B, let's say A is not error free and A has AM plus or minus delta A. A is represented like that, and B is also not error free, and your B is plus BM plus or minus delta B. Then what do you do about Q? First of all, will Q be error free? The answer is no, because A has some error, B has some error. So whenever you're carrying out an algebraic operation with A and B, and that is resulting into Q, then Q will obviously not be error free, right? That makes sense. Okay, and the same analogy, like the way I told you, the first trial will be A1, B1, second trial will be A2, B2, nth trial will be AN, BN. Every time you multiply, first time your Q1 is A1, B1, nth time your Qn is AN, BN. So every trial is giving a different Q, because A and B are changing, so Q will obviously change with every trial. So if Q is different for every trial, then that automatically should tell you that Q has some error associated with it. So Q is not error free. Same analogy. In fact, in all these four, we will give the same analogy. So from 3 and 4, I will not repeat this. I will try not to repeat it. I have a habit of repeating stuff so that important things get registered in your head. Nevertheless, the question is, now we know, first of all, we know that Q is not error free. So Q is some Qm plus or minus delta Q, right? Because it's not error free. So the question is, what is this Qm and what is this delta Q for this operation? For addition subtraction we saw, but what is it for multiplication? The process is the same. Just substitute A and multiply this with B. B is nothing but Bm plus or minus delta B. And now when you multiply these, you get Am into Bm. First term, like you have 2 terms, right? 2 into 2. So you'll have 4 terms here. So Am into Bm is your first term. Next you have, keep your plus or minus aside. Okay, keep your plus or minus aside, because finally we will represent that. So plus or minus, let this be, you have delta A into Bm, plus or minus you have delta B into Am, and then you have plus or minus delta A into delta B. I just hid a little, so let me just hide my video for a while. I just hid a little data. So right, does this make sense to you? This is simple, correct? So what I have 1, 2, 3, 4 terms here. What I want you to know is I will neglect this 4th term. Why will I neglect it? Because it's very small compared to 1, 2 and 3. Like let's say your Am is nothing but 1 plus or minus 0.001. Your Bm is nothing but 2 2 plus or minus 0.002. When you multiply AM into BM, what will you get? First term will be AM into BM, which is 1 into 2. Second term will be plus or minus delta A, which is 0.001 into 2. Third term is plus or minus 0.002 into 1, and fourth term will be 0.001 into 0.002. Now carry out this multiplication. Carry it out. You will have 2 plus or minus 0.002 plus or minus 0.002 again, plus or minus 0.0000. How many? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So can you see? First term is 2, second term is 0.002, third term is also 0.002, but fourth term is 0.00002. In fact, 5 zeros too. So this is very small, no? Because delta A and delta B are very small, so their multiplication will be even more small. So obviously I can neglect it when compared to 1, 2 and 3. Which is why now I will change this equality to approximate, right? We keep doing that in physics. Whenever we approximate or like we neglect terms, then we will have to change Q to it is approximately equal to AM into BM plus or minus delta A into BM plus delta B into AM. Okay. So guys, this is what I want you to know. This is your QM. This is the mean value of Q, and this quantity that you see here is the delta Q, error associated with Q. Now if I ask you, what is the fractional error? What is the fractional error in products? In product of two quantities. Well, formula for fractional error is simple. It is delta QM by QM, right? Error by mean value. So what is the error? We just now we saw it is delta A into BM plus delta B into AM. It is delta A into BM plus delta B into AM. And obviously your fractional errors are also plus or minus. Always fractional errors are also plus or minus. So we'll put a plus or minus here. And QM is nothing but AM into BM. So fractional error here is nothing but plus or minus delta A by AM plus delta B by BM. This is the fractional error. So three things that we saw here. Let me just quickly revise. You can check this derivation again because it will be recorded and it will be put up. So you have, whenever you have two quantities, Q is equal to A into B, then fractional error of Q, which is nothing but Q mean by Q mean, that is only your fractional error, right? Delta Q by Q is nothing but plus or minus delta A by A plus delta B by B. Okay, just now we derived it. And obviously using this you can also represent Q as QM plus or minus delta Q, where your QM is AM into BM and your delta Q is nothing but delta A into BM plus delta B into AM. Okay, so got it? Whenever you have did this whole thing make full sense to you? Let me just get myself back. I hope you paid attention. So this is how you represent product of two quantities which have errors associated with them, right? This is how you find QM and this is how you find delta Q. Your all that your job is your job is to find what delta Q and what delta QM are for a given operation, right? So as you can see in all these, your Q is A plus or minus B, here your Q is AB, here your Q will be A by B, which we will see now, and then here your Q will be A power M divided by B power N. These four algebraic operations are common, and that's why we'll have to see them. But the point that I'm trying to make here is, in all of these, there will be some error associated with Q because there are errors associated with A and B. So if there are errors associated with Q, then in all these four cases, my Q will be some Qm plus or minus delta Q. And in all these four cases, I will have a fractional error, delta Q by Qm. The only thing is, Qm and delta Q are different for 1. Qm and delta Q are different for 2, different for 3, different for 4. So like for all these four cases, my Qm will be different and my delta Q will be different. And hence my relative or fractional error will also be different, right? So I have already calculated Qm and delta Q for 1 and 2. Now we will look at the same for 3. And the procedure is going to be very similar, okay? So you have Q is equals to A by B. Okay, this is your division. Your A is AM plus or minus delta A, which means there is some error associated with A. Your B is nothing but BM plus or minus delta B, which means there is some error associated with B. If there are errors associated with A and B, then when you divide these quantities, there will be some error associated with Q, right? We have been seeing this for the past 2 cases now, so I will not explain in detail why will there be error in Q. You can check that analogy in the previous 2 sessions. In the previous 2 derivations, like the derivation for addition, subtraction, and derivation for multiplication. And the analogy that you see here, the same analogy you'll have to apply here to understand why there will be error in Q. But let's say now we are convinced that there is error in Q. So Q will be nothing but Qm plus or minus delta Q. My job is to find what this Qm is and what this delta Q is. Okay. So it's not very difficult now. What we have to simply do is Q will be nothing but A by B, right? But A is nothing but AM plus or minus delta A, and divided by you have BM plus or minus delta B. Okay. Now what I want you to do is take A common from this, AM common from this. So when you take AM common from this, you have 1 plus or minus delta A by AM, divided by you have BM into 1 plus or minus delta B by BM. Okay. Whereas your Q is nothing but Qm plus or minus delta Q, correct? So Q is nothing but Qm plus or minus delta Q, which is nothing but AM into 1 plus or minus delta A by AM into BM divided by BM into 1 plus or minus delta B by BM. So I want you to take Qm common from this. You will very soon you will know why I am taking Qm, AM and BM common from the brackets. It's because I want to use binomial approximation. You guys still don't know what binomial approximation is if you haven't done binomial theorem in mathematics, which is I think in 12th class mathematics. So only if you do that chapter, only if you do binomial theorem in 12th class mathematics, you will exactly know the reason why I'm taking these quantities common and what I intend to do. But for now, even if you don't understand it fully, just accept what I'm going to say. Ideally, you should be explained with binomial theorem before, and then you should be taught this approximation. But since you don't know binomial theorem, you'll just have to accept it, right? So from here, first of all, what I can see is that Qm into 1 plus or minus delta Q by Qm is nothing but AM by BM into 1 plus or minus delta A by AM divided by 1 plus or minus delta B by BM, right? So first of all, the first analogy that I want you to see here is Qm is equal to AM by BM. So first confirm that Qm is equal to AM by BM. So I got my Qm. First part of the job is over, right? Where did I start? I started here. Q is equal to Qm plus or minus delta Q. I got my Qm. My Qm is nothing but AM by BM. But what I still don't know is delta Q. Once I get delta Q, then my job is done. How will I get delta Q? So from here, I will have to make some approximation. So what I want you to do is take this denominator to numerator. So you have 1 plus or minus delta Q by Qm is equal to 1 plus or minus delta A by AM into 1 plus or minus delta B by BM power minus 1, right? Because I'm taking it in the numerator. And now I will use binomial expansion. Let me just hide myself. Now I will use binomial approximation. So whenever you have 1 plus or minus x power minus 1, then this will be equal to 1 minus or plus x if x is very small compared to 1. This is the approximation that I'm going to use. I'm giving you the approximation in a box. Maybe you will not understand the full meaning, but nevertheless you can just accept it for now. So whenever I have 1 plus or minus x power minus 1, then this somehow becomes equal to this. I can't tell you why it becomes equal to this right now, but for now you'll just have to accept it. When you study binomial theorem, you will know why this becomes equal to this, but for now just accept it, that if your x is very small compared to 1, then this will happen. And here delta B by BM is very small compared to 1. Why? Because B will be something like 2 plus or minus 0.002, right? So this is your delta B and this is your BM. So delta B by BM is a very small quantity. It is 0.002 divided by 2, which is 0.001, which is very small compared to 1, right? Delta B is a very small number compared to B, so delta B by BM will be an even smaller number compared to 1. So here also I will use the approximation that I have given to you in the above red box. And what will that approximation be? It will be 1 plus or minus delta A by AM into 1 minus or plus delta B by BM. Right? I will use this approximation. So when you have, so this somehow became equal to this because of this, right? And I was able to do this because delta B by BM is very small compared to 1. Just the way here x is very small compared to 1. Now I'll expand this and I should get 4 terms, plus or minus delta Q by QM is equals to 1. 1 into 1 is 1. Then you have, excuse me, then you have 1 plus or minus delta A by AM minus or plus delta B by BM. Then you have plus or minus delta A by AM into delta B by BM. Now guys, once again you will ignore this. Why will you ignore this? Because you have 4 terms here. 1, 2, 3, and this is your 4th term, and your 4th term is very small compared to 1, 2, 3. Once again the same logic, because delta A and delta B are getting multiplied and these are very small, like delta A is 0.001, delta B is 0.002. When you multiply them, you will get 0.1, 2, 3, 4, 5 zeros and a 2, right? So this quantity 4 will become very small compared to 1, 2, 3 automatically. So that is the reason why I'll have to neglect it. I have to ignore it and I'll just have to take these 3. Why I'm taking so much time to derive is so that you understand these expressions. Otherwise what will happen is you will just end up memorizing it without knowing the process, and then you might commit some mistake in the exam. So finally, from the previous expression, we ended up ignoring that 4th term. So now this is all that we are left with. This is all that we are left with because we have anyways ignored that 4th term. Okay. So it's nothing but 1 plus or minus delta Q by QM is nothing but equal to 1 plus or minus delta A by AM minus or plus delta B by BM. I want you to notice this. Notice the fact that this plus or minus here and there is minus or plus here, right? But anyways, I can cancel out 1 here and then this plus or minus will go that side, right? It does not make any sense. So the point is delta Q plus or minus delta Q by QM can be 4 values. There are 4 possible combinations. What are the 4 possible combinations? Either you have a delta A by AM oh sorry, either you have a plus delta A by AM plus delta B by BM, or you have a plus delta A by AM, or you have a minus delta B by BM, or you have a, I just hid something, so I'll have to pause my video again. Then I can either have delta A by AM minus and this plus. Finally, I can have minus delta A by AM minus delta B by BM. Once again, I have 1, 2, 3, 4 possible combinations. Which of these 4 will I choose? That is the question to you. Which of these 4 will I choose? Obviously, just like the first case where we had 4 errors, we chose the one with the greatest numeric value. Here also we will choose this, because here quantities are being added, so obviously it will be the greatest value. 2, 3 and 4 we will ignore because they will obviously be smaller than 1. So this is what I will take. Finally, my relative fractional error is delta Q by Qm is equal to plus or minus. Obviously, whenever I'm using relative fractional error, I will have to put a plus or minus, but that's equal to plus delta A by AM plus delta B by BM. Making sense? And from here, I already know Qm, right? We had already calculated Qm was nothing but equal to AM by BM. Qm was nothing but equal to AM by BM. So from using that, I can get delta Q. But anyways, what I want you to notice is this relative error or fractional error. This fractional error that we have just derived is the same fractional error that we got in multiplication also. Let me go back to the multiplication slide. Look at this. This is what is the fractional error in product? This is the fractional error in product. Like delta A by A plus delta B by B, right? And here in division also, we have delta A by A plus delta B by B, right? The same thing, which means fractional error did not change for division. Now that's interesting. That's very interesting. So what I'm trying to say here now, when you have a quantity Q is equal to A by B, then delta Q by Q is nothing but plus or minus AM by delta A plus BM by delta B, where A is nothing but AM plus or minus delta A and B is nothing but BM plus or minus delta B. And in fact, when we have multiplication, then also delta Q was the same only. Then also it was delta A by A plus BM by delta B. Sorry, right? The only thing that was different was here your QM is AM by BM, and here your QM is AM into BM, right? And because QM is this is QM by the way, delta Q by QM. Because QM is different for both, delta Q will be different for both, but relative or fractional error is the same. So note, relative error is the same for division and product. Delta Q by Q is the same, but delta Q is different for both, and QM is also different for both. In fact, QM here we are able to see. Sorry, this is Q, it is equal to into B, right? I hope you are not getting lost in the picture, right? Even if you are, then just come back and revise, right? So I want you to join all pieces of information that I have been adding from the previous class by the time you finish this lecture. So when you finish this today, watch all the 3 again so that you're completely clear with how we have come so far and what we are trying to do here, right? So QM is this for division, QM is this for multiplication, but delta Q by QM is the same for both. So obviously delta Q will be different for both, right? Just verify that statement for yourself. And with this, we have also finished, let's go to the first slide. We have finished analyzing how to report errors in division. So we are done with how to report errors in sum or difference. We are done with how to report errors in product. We are done with how to report errors in division. There are similarities between sum and difference. There are some similarities between product and division. I want you to verify those similarities again for yourself. The similarities are not the same, right? The similarities are not the same for this pair and for this pair. The similarities are different, but I want you to verify what those similarities are. Coming to the final one now. This is the fourth one. So Q is equal to AM power BM. AM power BN in fact. A power N power B power M by B power M. This is your Q. For these cases, what do you do? What do you do for these cases? This will get slightly complicated because you need to know logarithms and differentiation to solve this case. Now the point is, some of you might know what logarithms are. You might know, but you still do not know what differentiation is. This is the problem. You don't know this. So I will derive it in front of you right now, but I just want you to watch the derivation. So my sincere note to you is, just watch the derivation, how I derive. So obviously, first question, there is some error in A, there is some error in B. Where A is nothing but AM plus or minus delta A, where your B is nothing but BM plus or minus delta B. So there is error in A, there is error in B. So obviously this expression, as a result of this expression, Q will also have some errors associated with it. So Q will also be some QM plus or minus delta Q, and Q will also have some fractional error, right? There will be a delta QM by Q. So we have to calculate this delta QM by Q. How will I get this? So now, to get QM, to get delta Q, and to get this, I will do some derivation. I just want you to watch it because you will not understand it fully unless you know differentiation. So, second point, after you finish learning differentiation, which you will, in this bridge course only, I will teach you how to carry out differentiations. So only after you finish differentiation, you come back and try deriving it yourself. So after you finish differentiation, come back and derive this yourself. Because I don't want you to remember all these formulae. I want you to know the derivations so that even if you forget it in the exam, within a minute you can derive it on your own and solve. Okay. So coming to the derivation quickly. So this one I will go quick because you will anyways not understand. So you'll have A power M into B power N. I will take log on both sides. So log Q is nothing but N log A minus M log B. Some of you will know this step because if you know logarithms, you will know this step. But next step, most of you will not know. So differentiate on both sides. So when you differentiate on both sides, you have dq by q is equals to n dA by A minus m dB by B. You will first of all, you will not know what this dq is. What is this d? Suddenly where this d has come from. Don't worry. When you learn differentiation, you will know. When we have a function f of x as something, then we differentiate it like this, df of x by dx. Then this d, you will know the meaning of what this d is. So when you understand the meaning, then you will know this step, what I have done here. Okay, so don't worry about it now. So this d is only your delta actually. And right now, since you don't know what this d is, you don't know how this d has become delta. But this is delta q by q is equal to n into delta A by A. In fact, this is your A mean only, A m minus m into delta B by B. And this is your BM only. Okay. That's all. you got your fractional error. But the point is to know this derivation yourself. You have to first learn differentiation and then come back and watch this. Okay. So, in fact, it doesn't stop here. Since this is fractional error, there will also be a plus or minus here. In fact, it doesn't. The plus or minus has already been carrying. In fact, my bad. Plus or minus has already been there. Plus or minus has already been there. So again, you'll have 4 combinations of errors. You'll have plus n into delta a by am, plus m into delta b by bm, comma, plus n into delta a by am minus m into delta b by bm. In fact, let me write these 4 errors in the next slide. So you'll have plus n into delta a by am plus m into delta b by bm. First error. Second error is plus n into delta a by am minus m into delta b by bm. Third error is minus n into delta a by am plus m into delta b by bm. Fourth error is minus n into delta a by am minus m into delta b by bm. And which of these 4 will you choose? Once again, you have 4 terms, 1, 2, 3, 4. You will choose the numerically biggest term, which is the first term. So this will become your error, right? So your delta q by q is nothing but plus or minus. You will only choose this, okay? Only choose that because that's the biggest term numerically. M into delta v by b. So that's all. Whenever you have a quantity which is a power n into b power m, then fractional error is got like this. And how will you get qm? Qm is simple. Qm is nothing but am power n divided by bm power m. Now this m and this m are different. This is power m and this m represents mean. This subscript m represents mean, right? So you had a is equal to am plus or minus delta a, right? Delta a minus use n delta a by it. But we can't help it unless you know derivation. You come back to this, it will make sense. But this fourth derivation you would have completely not understood, right? Right from the first step you would have not understood. So once you study differentiation, once I finish teaching you differentiation, then come back to this, you'll be able to derive it yourself. So with this, thanks for watching, guys. I hope you learned something new. I didn't have a lot of messages in the chats today, but I hope to see some more interactiveness tomorrow when I give you problems to solve in the class. Any doubts, you can put it in the comments box and then we'll catch up again soon. Share about this bridge course with your people and get more people for this. It'll be good for everybody. Thank you for watching. See you again. Bye.